In our next equation, we need to write a net ionic equation for it, but first we're going to write our product, and we have two compounds here reacting, so it's going to be a double replacement reaction, and we'll produce two compounds, and we were told in the problem that silver chloride is going to be a precipitate. So when I work this, I write my products as they switch partners. So I look at this, Ag is a +1, Cl is a -1. So AgCl is my formula, and it's going to be a precipitate. So I'm going to write it down as a solid. Sometimes you'll also see it written down as a P instead of an S to indicate that it precipitates out of solution. So we have that being formed, and the other thing that's going to form is aluminum nitrate. Now, aluminum's a 3+ charge, nitrate is a 1-. So I'm going to need 3 of those nitrates. So it's going to be Al parenthesis NO3 parenthesis 3. And that's going to be aqueous as well. So when we write this down as a complete ionic equation, what we're going to get is Ag plus, I'm not going to bother with the aqueous right now because I'm having a hard time writing, plus NO3-. So those are my aqueous ones, and AlCl3 also aqueous, so it's going to be Al3+, and Cl-, both aqueous, producing, this is a solid, so do not break it up into ions, AgCl, that's a solid, and this last one is aqueous as well, so I'm going to have aluminum ions, Al3+, and nitrates, NO3-. Okay, so we look here and we're looking for things that are common to both sides, and the nitrates are common, so we can get rid of those spectator ions. The aluminums we can get rid of, and we're left with silver ions that are aqueous, and chloride ions that are aqueous, and it's going to produce AgCl, a solid compound. So as I count here, on the left I have 1 silver, on the right I have 1 silver atom, on the left I have 1 chlorine, on the right I have 1 chlorine. So my atoms at the moment are balanced. I look at my charges, I have a +1 and a -1 on the left, which add together to give me 0. And AgCl has no charge, so it's also 0. So this one also is balanced as written with just one of each thing. So this is our net ionic equation that's also balanced. Now, how do we answer the question of whether a precipitate forms or not? There are general rules for determining the solubility of an ionic compound. If something's not very soluble in water, then it's going to precipitate out of solution. So some of the general rules is, as far as what's soluble, a salt of an alkali metal and ammonia, that's going to be soluble. So salts of alkali metals and ammonia are soluble. Nitrates are soluble, and so are chlorate salts. Now remember, salt just means where you have a positive and negative ion coming together here. So nitrate and chlorate salts are soluble. Sulfate salts are soluble, but with a few exceptions. So it's insoluble if sulfate is with lead 2, with silver, with mercury 2, with barium, with strontium, or with calcium. So sulfate salts of those 6 ions would not be soluble. They'd come out as a precipitate. And then other soluble salts are chloride salts, with the exception of lead 2 with chloride, that's insoluble. So is silver chloride, which we saw earlier, and mercury 1 chloride. Now, in terms of other insoluble ionic compounds, pretty much all your carbonates, phosphates, chromates, sulfides, and hydroxides are insoluble, with few exceptions. Now, this shows when a precipitate forms what's actually happening. You put in your 2 liquids together, where you have ions dissolved in water in both cases. You mix them together, and in this top picture, we can see that we have water with copper chloride, copper 2 chloride mixed in, and so it's dissociated into these chloride ions and copper 2 ions. Down in the bottom solution, we have sodium hydroxide solution. And so we have sodium ions and hydroxide ions dissolved in water as well. When we pour the two together, we end up forming a solid, as is shown here on the left. As they mix, we end up with sodium and chlorine staying aqueous. So you see on the right side of this circle that sodium and chlorine are separate from each other. They're not bound together, so they're dissolved in the water. But on the left, you see the copper hydroxide forming an ionic solid. We form a crystalline solid that comes out as a precipitate, and it's in a very orderly pattern. We can see that's a solid coming out. It's not just mixed in with the water anymore. Now, in terms of will a precipitate form when you mix aqueous solutions of ionic compounds, what you have to do is look at what products would form and look at what's insoluble and see if either of the products being formed would be insoluble in water. So the first thing we're looking at is when silver nitrate and sodium sulfate solutions are mixed together, are we going to get something that is insoluble? Well, we would take the silver ions and the sulfate ions, and they'd go together, and we get silver sulfate. So we look down below, and it talks about sulfate. At the very bottom, it says sulfate is insoluble when it's combined with, oh, there it is, Ag+. So with silver, silver sulfate is going to be insoluble. So we can say that, yes, silver sulfate is going to precipitate out of solution. NaNO3, if we double check it, we don't see anything down here where I've summarized what's insoluble. I don't see anything that says anything about nitrates. So sodium nitrate is going to be soluble. Our next one is ammonium chloride and barium nitrate mixed together. So we're going to have ammonium with nitrate. And once again, we didn't see anything about insoluble nitrates, so that one must be soluble. But what about the barium and the chlorine? So barium chloride. As I look below, looking for chlorides, oh, here it is, chlorides right here. Chlorides insoluble with lead 2, silver, and mercury 1. But it doesn't mention anything about barium, so there will be no precipitate that forms because both of the products, ammonium nitrate and barium chloride, are soluble in water. Our next example, calcium chloride and potassium sulfate. We'd end up with calcium and sulfate together. So I look down here at my sulfates, which are on the bottom. Sulfates are insoluble if it's with Pb2+. Ag+, Hg2, 2+, Ba2+, S, down here at the end, Ca2+ with sulfate is going to be insoluble. So right there, we know that we get a precipitate. That will form a precipitate. And KCl would not form a precipitate because notice chlorine is only insoluble with lead 2, silver, and mercury 1. So we do get a precipitate of calcium sulfate. And our last example, when lead 2 nitrate reacts with hydrochloric acid, then we would put the Pb with the Cl. So we'd have lead chloride, and if I look for my chlorides, this says that Cl negative with Pb2+ is insoluble. So we should say yes, lead 2 chloride, it would be insoluble, so that would precipitate out of solution. It would be a solid that would form. These were some examples showing you how you can use the rules of solubility and insolubility to figure out and predict whether a precipitate would form or not. I hope you find this to be helpful, and we will watch these videos together in class.